Solving systems of equations by substitution. This is a photo of the John and Mabel Ringling Museum of Art in Sarasota, Florida. It was built by John and Mabel Ringling. John Ringling made his fortune with the Ringling Brothers Circus. Here is an interesting photo taken on the grounds of the museum. Solving systems of equations by substitution. When solving a system of two equations, what we're looking for is one ordered pair that can be used in both equations. In other words, we have to find the same x and y to satisfy both equations. We could just guess until we find the right pair, but that could take forever. We could also solve by graphing both equations, but that method is not always easy. We will look at an example to see another way to solve the problem. We have 2x plus 3y equals 12 and y equals 1/3 x plus 1. The equation on the right says that y is the same as 1/3 x plus 1. But since y is the same in both equations, this y must also be the same as 1/3 x plus 1. We can substitute 1/3 x plus 1 for y in the left equation. So that's what we do. We replace y with 1/3 x plus 1 using parentheses to group the substitution. Now, since there are no like terms in the parentheses, we can use the distributive property to clear the parentheses. 3 times 1/3 is 1, and 3 times 1 is 3. Now we collect like terms and solve for x. We get x equals 3. Since the same x should work in both equations, we can substitute back into either equation to find y. We have room here, so we substitute in for x and we get y equals 1/3 times 3 plus 1. Canceling the 3, we get 1 plus 1, or 2. So x equals 3 and y equals 2. Now we should check our answer, and we should check in the equation that we did not use last, because if we check in the last equation, then we won't find any mistakes that we made when we found x. So we're going to check in 2x plus 3y equals 12, and we get 2 times 3 plus 3 times 2 equals 12, 6 plus 6 equals 12, or 12 equals 12. So it checks. X equals 3, y equals 2. Here is another example. X plus 3y equals 4, and 3x plus 6y equals 10. In this case, neither equation has a variable by itself, but we could easily solve the first equation for x. So we subtract 3y from both sides and get x equals 4 minus 3y. Since x equals 4 minus 3y, we can substitute into the second equation and get 3 times the quantity 4 minus 3y plus 6y equals 10. Once again, we use the distributive property to clear the parentheses, and we get 12 minus 9y plus 6y equals 10. Collecting like terms gives us 12 minus 3y equals 10. Negative 3y equals negative 2, or y equals 2/3. Since the first equation is already solved for x, that would be a good equation to use to find x. So we substitute to find x and replace y with 2/3, giving us x equals 4 minus 3 times 2/3. Canceling a 3 gives us x equals 4 minus 2, or x equals 2. We have our answer. Now we need to check. And as we did the last time, we check not in the most recent equation, but in the equation that we did not just finish using. So we check an equation that you did not use last. In this case, that's 3x plus 6y equals 10. Substituting in, we get 3 times 2 plus 6 times 2/3 equals 10, which gives us 6 plus 4 equals 10, or 10 equals 10. So we know we have the correct answer. X equals 2, y equals 2/3. To summarize, solving systems of equations by substitution, we get a variable by itself in either equation, substitute for that variable in the other equation using parentheses, solve for the variable using your first answer, substitute into either equation and solve for the second variable. And finally, we check in the equation that you did not use last. When should we solve by substitution? Substitution works best if one variable is already by itself. If you can easily solve for one variable without getting a fraction, then substitution is usually the best method. If solving for a variable results in an expression with a fraction, then there is an easier method, which we will learn next. When solving by substitution, write the equations on your paper side by side like this. Do not write the equations one on top of the other like this. Textbooks just write it this way to save space, but it doesn't leave you enough room to work. Always check your answer. Check in the equation that you did not use last. If you do check in the equation that you used to find the second answer, then you may not catch your mistake.